Okay, good morning class. So when I did the recording of this lesson, for some reason or other, I used somebody else's phone and it just didn't work for me. So I just need to re-explain this here. So we're looking at more complex equations involving surds. Okay, more complex equations involving surds. And this is the examples for exercise 12 on page 22. The question is solve for x. So we got the square root of 2x plus 6 plus 1 equals the square root of equals x. So what do we do first? Take the 1 over the equal sign. And then now it reads the square root of 2x plus 6 is equal to x minus 1. Now what? Square both sides. So the reason why I took 1 over the equal sign is to isolate the root, to get the square root on its own. Alright, so the square both sides. So that of course cancels. Square root cancels square, or square cancels square root. So I got 2x plus 6 is equal to first term squared, give me x squared, that times 2 minus 2x plus 1. If you don't know how to apply the binomial square, what do we do? So write it out twice, we multiply them. So take everything to one side of the equal sign. So I got x squared minus 2x plus 1 minus 2x minus 6. Now what do we do? So x squared in like terms becomes negative 4x minus 5. Alright. Trinomial. So we x and x, 1 and 5. Do we add or subtract our products? Subtract. The bigger one must be negative. In other words, x is equal to negative 1 or x is equal to. But we stop here. We must check. Alright, so what we do is because the sum moves from false state to a positive, because if we look at from a square root we don't get a negative. So this could be negative if x is less than 1. Not so, because if x is less than 1, which is 0, 0 minus 1 is negative 1. Can you see here? So here's a condition that needs to be met here. This number must be positive. So moving from a negative state, which it can be negative, by squaring it, it will become positive. Can you see that? So going from a false state to a true state, that is why we need to check here if our ratio or our solutions actually works. So what I do is I take the original sum. Okay? This is how I check. Do I need to show this on the side, people? No, you don't have to show this. I'm just showing you what I'm doing. So I test for x is equal to negative 1. Okay? So what I do is if I say x, I put a negative 1. So it's 2 into negative 1 plus 6, the square root thereof, plus 1. Let's see what that equals. If this is equal to negative 1, the job is done. It's correct. If it's not equal, then that means to say that is not a solution. Okay. Let's test. That would simply be the square root of 2 multiplied by negative 1 plus 6 plus 1. Gives you 3. Does that one work? No, so no solution. Okay, and we check the other one. The left hand side of the equal sign, of course, going to be the square root of 2 times 5 plus 6 plus 1. That's equal to 10. 16, 4 plus 1 is 5. And x is 5, not so? Yes. So, is the left hand side equal to the right hand side? Yes. So therefore that one works. This left hand side was not equal to the right hand side. Can you see that, people? It's only when the left hand side is equal to the right hand side the solution will then work. And as I've indicated before, that you'll get cases where both are solutions. The cases where one is a solution, and this case is where none of solutions. Okay, you guys understand?
Yes.
But it's always good to check. If you leave this out, people of course going to lose one more. Okay, so always check. And in the exam, we always try and get one that doesn't work. And that is how we know if you're checking or not. Okay. You all okay with that?
Yes.
Alright. So with that, you should have been able to have done exercise 1.12.